So this panel will be focused on lessons from orbit, basically from all of these 5 people here who've launched many satellites to space at this rate. Some cases, most of the cases you'll recognise. We had Joe, Tibor, Stefano, and Tom talk. But we've also got Pablo Durbin here, who came over from Spain, and he's the CEO of Hydra, who is working on a constellation for Internet of Things, picosatellites. And yeah, they're going to be all sharing their experiences, and the panel will be chaired by Tom. But if you guys have any questions, I've also got a mic, and yeah, let's learn more together from these guys. All right, round of applause.
Thanks, guys. We good? Can we hear you? Yeah, cool. So we done a session last year, and it was the most viewed YouTube video of the show. So hopefully, it'll be interesting. A big part, I think, of the PocketQube community, or what I hope the PocketQube community really will be like over the next sort of so many years, is folks that have got to orbit can try and feed back some lessons learned to the teams that are building or planning to go up in the next year or two. So we got a panel, obviously, of folks that have been to space with their satellites. They've learned lots of lessons, and hopefully be quite an interesting conversation about what they've learned and what they think about these things. So yeah, maybe just start with Pablo, obviously, as someone that hasn't been talking today so far. But so Pablo is obviously, like I said, the CEO of Hydra. I think you guys have flown 4 missions now.
We have flown. We have launched up to 8 satellites with growing degrees of success, I would say.
Okay, cool, yeah.
Which is a good thing.
So what would you tell Pablo before you joined Hydra? Like, what was the first day at Hydra? What do you wish you'd known then that you know now from launching satellites to orbit? Okay,
well, before joining, I'm probably the least technical guy in this room. So but what have I learned is, okay. Even if you're launching very small PocketQubes that some people think they are toys, they are not toys. This is complex technology, and launching it's a complex project. There's a lot of things, not only the technical stuff, but also the licensing, the project coordination. My recommendation would be, it sounds stupid, but really have a plan. Really try to build a plan that considers everything, and not only building the which is of course is important, but also the launch, the coordination with third parties like you. It's the licensing, the environmental testing you need to do, the functional test you need to do before and after the environmental testing. It's a complex project, so you should have. Sometimes, we are a small company. We don't have. It's hard for us to have a kind of a project manager figure. Probably I'm the one who does that. But you need to dedicate specific resources to managing the whole process, because it's really. It's not. There are, as I say, there are a lot of. I was surprised. There are 100 things that you need to take into account to go to space. In the end, if you succeed. It's very, yeah. And even because we didn't always succeed, but we learned a lot. And that was the only way to go to the next launch with more knowledge and do it better. And as I said, our success has been increasing from launch to launch, and that is because we took advantage of the lessons learned in the previous ones. So it's really been an amazing process, and we learn a lot, and we learn with you also. It's been really interesting to work with you in this project.
Yeah, absolutely. So have a plan.
Yeah.
I think it's a fair point that project management is one of those. I wouldn't say dirty words in the Pocket community, but obviously projects tend to be founded by engineers who are really passionate about getting their mission to orbit, and often that skill set doesn't always overlap with someone that's Gantt chart centric. That's certainly been my experience. So yeah, I totally agree with that. So that's totally fair point.
And we also know what you're going to do day one after launch. I mean, because again, you think that when the launch is done, it looks like a deadline, like a milestone, but there's a lot of work up to do that after the launch. I mean,
yeah, so like trying to find a satellite. Yeah, we've been through that recently as well, and like trying to get the ground station running, and just getting. I know your pain. But yeah, you guys have made a lot of progress on that front. So good stuff.
I mean, there's a lot ahead of us, but yeah, we've done. We're quite happy with the progress we've made. I mean, it's come a long way.
Cool. So Tibor, obviously, how many? So you've done 4 or 5 PocketQubes now?
Four PocketQubes
cool.
and 1 CubeSat.
You're on the 5th one, 1 CubeSat, yeah. Cool, gotcha. So, like, obviously we chatted last year and stuff, and you've got another year worth of experience under your belt. So, like, what would you say is the big surprises beyond just some stuff that Pablo was saying there? Like, what would you say has been surprising to you on the whole process? And what would you wish you'd known, like, I don't know when you started, because I think we met probably 2017 was the first time, the first Delft event for PocketQubes. Like, what do you wish you'd told Tibor? If you were meeting old Tibor in 2017, what do you wish you had told him about PocketQubes? Well, what did you get wrong, and what did you surprise you?
So back then, with those missions, with the previous smoke missions, I think we actually did a better and more thorough job, mainly because of in this case, the reduced development time. So back then, the development time for Smoke 1 and Smoke P was like almost 5 to 6 years. Now MRC was built from scratch in 1.5 years. With the supply chain issues and the missing chips, and we couldn't really buy anything that we wanted. We could not reuse a lot of the components that we wanted to use, for example, because they were useful in the previous missions. So what I would say is, if something works and it's reliable, keep a stock of it for yourself for future missions. That's I think a good advice. And don't just make one model, like flight model. Make at least two. And I think in one of the maybe you guys showed that you made 5. I think that can come in handy. Even if you don't use them, you can show it around in a showcase.
Yeah, so yeah, definitely like stocks. We've found like processors going into stock and things like that. And if it does work, like we've been struggling to find the processors we use in Unicorn and things like that. So that sounds really good. Maybe open up to Stefano as well. Like, what would you add to that? What would you wish you'd known about Delphi PQ when you started, or the processor doing Delphi PQ? And you have 2 years of experience now with that mission.
Well, as I said, build 5 is probably one of the lessons learned. We've been through kind of assembly and integration in 2020, sort of fantastic year, no components available. And in that sense, if you break the only one that you have on the table, then you're stuck for months. So in that sense, we started building a little bit more in an automated way, also invest in testing. That's something we initially didn't have too much. Every test was kind of thought of, I don't want to say on the spot, but more, we didn't really have a full overview from the beginning till the end. One of the things we changed dramatically halfway into it was actually go into automatic testing. So that's a standard procedure for industry that has been the same for automotive, but the space world is not really pushing so much into that. I mean, only recently. Imagine kind of emulators or things you could use to plug your satellite onto a computer. Your computer has an automatic procedure. You test it. Maybe your test takes 1 minute and it tests all the functionalities. You have changed only one of them, but don't bother. Retest everything. These kind of testing strategies or habit actually in the end will give you a much better system, much more reliable. You really don't bother anymore. If the test takes 3 days, you will only do it if you have the time and if all the stars align. But if your test takes 3 minutes, repeat it 3 times a day. It's just not going to change anything.
Gotcha, cool. Yeah, jump in, yeah.
So yeah, this testing part is a very crucial component. I can agree with that. One thing that popped into my mind, and I was talking about it, is interfaces. Defining the interfaces is very crucial. So if you know what your subsystem has to deliver to the other subsystem, and you treat your subsystem as a box, inside it can do whatever, but on the interface, both parties should be aligned, and the one that has to expect something, the other one has to deliver exactly that. And otherwise, later on when you have the integration testing, for example, you can say that, okay, this subsystem is not working, and you don't really know what is happening. Maybe it's because the interface is not defined correctly. So yeah, interface is key.
Yeah, so that's one thing we really learned from you guys, because you came to do a fit check like probably 3 or 4 months before like we'd done integration. I think you're probably the only team, maybe one of the only teams that have came like to Glasgow to do a fit check on AlbaPod, and like that really impressed us on the way you guys were testing things. Maybe open up to Joe, so pass the mic along for Joe. So obviously Joe's been involved in a bunch of CubeSats, a few PocketQubes now, developing a bunch more PocketQubes. So like what have you learned from your experience in space, and what do you wish you'd known? Because you came to the first event, you came to the second event in Delft 2018, so 5 years ago. Like, what do you wish Joe 2018, what would you tell Joe 2018 and 2023, I guess?
I guess the first thing I would tell Joe in 2018 is stop. Don't do this. You're in for a long, hard road. The thing I would recommend as advice is get a team. Okay, if you're trying to build a PocketQube by yourself, you're going to miss things. You need to have people that you can bounce ideas off of and check you. And I don't know how many times when I was on my own, it's like, okay, and I get ready, like pre-assembly tests, it's like, okay, I think I got everything. And then I have a friend come over and look at it and says, oh, that's not going to work because of da-da-da-da-da-da, things you don't think of. So that would be the first thing. Second, start the regulatory process before you design. Okay, if you do not start with that in mind, that's where the project plan comes in. Start with your project plan. What does my regulatory look like? What are my supply chains look like? What is the build going to look like? I don't quite build in 5s, we build in 3s, but yeah, we build an engineering model, a flight model, and a backup. And if both the flight models fail, then we'll retest the engineering model so it can fly. Yeah. But yeah, you gotta think this through. Have that project plan. Start with your regulatory, then build the satellite. You'll save yourself a lot of effort.
Yeah, I mean, that's something that's almost cliche for us now is the regulation issue. You know, we see so many teams, like especially new teams, just underestimate the challenges, and it's one of these things you can't speed up. You know, like it's API A, API B process is what it is. You know, and it has a set amount of time, and you can potentially rush maybe getting your PCBs done. You know, you can pay more money, but you can't pay more money to get your license quicker. So 100% agree with that. Cool, so what have you learned from other teams perhaps? So obviously you guys have all flown, like what have you seen in other teams that you've been really like sort of motivated or inspired by, and what would you say like, because like for us obviously like, we're inspired by all you guys. You do really interesting stuff, and we have the luxury of seeing you guys come through. Like a lot of you guys have integrated in Glasgow now in the clean room, and we see what people are working on and things. So like, what have you taken from other teams that you have implemented potentially from the conference or speaking to people into your processes? Maybe Pablo, yeah.
Can you check the question? Sorry.
Yeah, just like, so obviously like no team is an island, so like what have you seen other teams do? So obviously we worked with Felix back in the day, and we gave him like a CAD model maybe 7 years ago, you know. So like what have you seen other teams do that you thought that's a really good technique, or that's something you really like and you've implemented it into your process?
Okay, yeah, I mean, yeah, we've learned a lot. I mean, it's the concept of community is really powerful, because I mean, as I was saying before in the lunch, I mean, you get a lot of from other teams, and you can see. I mean, we've learned about the mechanical problems that you face and how other people are solving them. We're always looking at in space. I mean, we're a business, and of course, a business has competitors. But in space, every competitor is a potential partner. So we're always looking at. And we look at it that way. I mean, we're always looking at what other people are doing because we know most of the people are more clever than us. So we really need to look at them. And so yeah, we learned a lot in terms of mechanicals, the way they manufacture. Every time I see a video of people, manufacturing I mean, it's really interesting because you see, hey, you see that guy did. I mean, that's really cool. I mean, let's copy that. Let's I mean, it's
yeah, I totally agree. I mean, like for me, it's the interesting thing. Obviously, we're doing Hillington. We got the big factory now, and it's like there's never been a factory of PocketQubes. So, like, what the hell does that even look like? Like, should there be a big factory? Should it be a small factory? Should it be automated? Should it be manual? Like, how the hell would you lay that thing out? So, like, taking things from even other, like, manufacturing, other companies and other sectors. And
yeah. For instance, we use a lot of, we gave a lot of thought to component selection. I mean, we of course, we wanted to use space hard components, but then they are expensive, so we want to also to manage the cost. So we look a lot at what the automotive industry is doing, because more and more cars, they're very, very complex machines. They have very complex electronics, and they need. I wouldn't say as hard as space grade, but they really need robust technology. So we are using some of the things that we know have been built for the automotive industry. We're reusing them in our designs, and we think it's working cool. I mean, it's working fine. So that's a way. There's a lot to learn from other teams and from other industries. I will say. Yeah.
Tibor, what do you think? Like, so what's stuff that you've seen out there, obviously, like from other teams that you think has worked really well, and to the point that you've implemented it into your processes? Like, is there any sort of examples you've seen of interesting things that other teams have done that you've said, yeah, that really makes sense for us to do? Because you guys have always been really hot in testing. So, like, did you guys initially start off being really hot in testing, or did that kind of come through seeing other teams being more testing centric, or yeah?
So honestly, it's a bit hard for me. This topic is a bit hard for me since, as a university, we try to be upfront in technology advancement. But what I found useful from other teams is, for example, standardization of components, for example, and this is the one thing that popped into my mind. So this might be a bit short-sighted, but yeah, as I read somewhere, as pioneers of this PocketQube industry, it's when you try to lead the community in these terms, in technology terms, more people get ideas from you than you from them. And I try to collect ideas more and more. Most of them we have somehow tackled already. So I try not to be too boasty or something like that, but yeah, that's my idea, or that's my opinion about this.
Gotcha, cool. Stefano, so like obviously you guys worked in Delphi Next back in the day. Was that
2013?
Yeah, so that's re-entered. So you've been around satellites for a long time, I guess, and then you transitioned to PocketQubes. Like, what have you seen other teams? So obviously you guys used to host the workshops. You'd see a lot of people come to Delft and sort of have many different plans, about what was going to happen, and then obviously you see a bunch of the stuff play out over time. So like, what have you seen other teams do that you guys have kind of went, right, we should be doing this? Because you guys have always been quite high on quality control, and Delphi Next being the classic example of that, working for over 10 years as a CubeSat that worked for over 10 years. Delphi C3, sorry. All right, sorry, yeah, Delphi C3. So like, what would you say you've seen from other teams that you thought that's what we should be doing at Delft?
Well, on one side, Delft was very focused always. I mean, I haven't been part of these missions from the early days. I've been more the caretaker for the satellites in orbit. But in general, if I look at the past and what was done, everybody in the end sort of ended up in other space companies. So they always took advantage from research institute and, I don't know, Airbus in the Netherlands. So the idea of testing, standardization, all of these things were very much in the DNA. Probably what we looked at others was, well, if you actually don't do that, if you sort of scratch a little bit, get it a little bit simpler, it still works. So on one side, that is maybe one of the things that pushed PocketQubes. It maybe gave them also a bit of a bad name. If you look at the early days, they sort of looked very much, yeah, take a bit of duct tape, stick it together, it's gonna fly. So that is maybe the extreme, so don't, please. But in the end, if you take the same philosophy as you would take for a bigger spacecraft, you can build a reliable mission. So maybe, yeah, to go back to the question, actually making things simpler was kind of the lessons we took from a lot of other teams, trying to remove rather than add. But yeah, then up to which point we stopped, that's maybe a bit of a personal choice. And for most of us, I mean, Shefkat as well, we've been doing work before in CubeSats or other missions. We kind of remained more on the sort of traditional side, closer to the space, traditional space domain in that sense.
Yeah, just to agree. I think like the keep it simple thing is really something that I think we got carried away, or I got carried away on Unicorn 2 in the early days about we could have everything, you know, we could have wheels and rods and payloads and cameras and everything, and it became a real nightmare to get that thing really like to the point that it's like stable and reliable. And you definitely do trade off like mission success, and you do have to burn through a bunch of satellites to get to the point that if you want to do a really advanced PocketQube, you know. So Joe, anything you've seen from other teams that you've sort of shamelessly copied and implemented in your own process?
Short answer, yes. I'm going to be honest. The perseverance that you've had with Alba, okay, that's rubbed off, all right? And my team will tell you there have been days when it's like, okay, that's it. Throw your arms up. You don't want to do this anymore. I see you guys. You've been in the trenches, and it's like, it's doable. And then I look at what's been built over here, how you crammed all that into a 3P, I'm still trying to figure that out, okay? That was amazing engineering. So it's looking at what people are doing, the different ideas that are coming about. It's like, oh, well, I just take that and put it in the back of your head. The whole Internet of Things, the idea of testing. Yeah, and those are all principles that I think they've rubbed off on us. It was like the first time I built it. Well, I think I was the first one to officially fly a brick in the PocketQube community, so I know how to fail. And it's like, okay, well, what did we do wrong? Oh, really? Yeah, but so it's really just, you don't realize what you're taking from the other teams, but to acknowledge it and see, here's this idea, or here's an idea for a panel that you didn't think about, or where this was connected. That's what I take away from it.
I suppose that's the whole point of the workshop, is like just people are doing a bunch of cool, interesting stuff, and you maybe don't realize that you met this guy a year ago, you seen what he's working on, and it sort of comes through years later in some decision or some design. So, cool. Maybe want to open up to the floor, because I don't want it to be too much of a kind of love in here, you know. Let's get some questions going, and what would you want to ask? So I think probably between the panel, there's probably about 30 satellites being, you know, built by people in the panel to some extent, or the companies or teams they're affiliated with. So do we have any questions for the panel on lessons from orbit?
Yes, we've got our first question from Pietro from SmartIR.
I don't think it's working.
I would like to know a bit about which testing are you normally performing? Yes.
I think if you look at the vast majority of the failures, and this is something, of course, universities are fond of doing these type of research, where do you fail? The vast majority actually comes from people not properly testing, so functionality. So functionality test is the first issue you have to sort out. So that's the main reason why we started putting in place this automatic test setups. So all the systems have a predefined test procedure. We have a test jig where you come with your board, stick it on top, run an application on the computer which will check out everything. So this gave us also a tremendous advantage, because during the development you might want to go more iterative, like they now talk about whatever agile systems. If you do small modifications time after time, that's a lot easier to get it to work. So that's why the automatic testing will make a huge difference in your reliability. The traditional, vibration and TVAC, those are typically useful. Well, vibration, you want to know if you survive. That's also a requirement to launch. Otherwise, yeah, you simply are not accepted on board. TVAC, you really, well, at least temperature is fundamental. You want to know if your satellite will stand low, cold and hot. If you don't have that, you don't know if it works. Vacuum typically gives you the equilibrium temperature, how much heat you radiate and you absorb. But for the rest, you might actually test the components separately, at least if they don't blow up. That's an important one. But typically, it doesn't really make a gigantic difference. Actual light, shine a lot of light on your satellite, have a lamp, and actually have your satellite charged fully. It's maybe a stupid case, but there was a team, I read it in literature, they actually made a mistake. The solar cells were actually swapped. Instead of charging the battery, they were discharging the battery. And that's why they never tested it all together. So in that sense, you really need to test everything separately. Be sure that you have something working, put it together, let it operate for days. We had it on the table for some of the things, they ran for like weeks, months. Some of the layers in the software were just on their own running for months. And then we came back afterwards, yeah, no error, fine, the software is fine, we can move on. So that is, I think, functionality is the first, very important one.
Any other questions?
Sorry, just a fun fact. I don't know if any one of you have tried to reverse supply a solar cell, but it glows red if you supply current to a solar cell.
Any more questions? These are questions for folks that launch software, but what do you want to know from these books? Nobody wants to know anything?
Go ahead.
Here's the question.
Another question about licensing. So, I don't know how, it's a fact, I don't know if it's real, but if I license my satellite in, for example, Spain, and I want to operate it from UK, is that allowed? Question mark.
Yeah, I guess
Just take that one.
I think as a deployer, this might be a question for you.
That's not a very good question.
Manufacturing and launching the satellite.
Yes.
Who needs to authorize the mission is the owner of the launching station.
Yeah.
But then you can operate it. Sorry to.
Now go for it. Yeah, go for it.
So it's the launching state that needs to approve the mission, which means that if you're a Spanish entity, then the Spanish government needs to approve your mission authorization, and then you can operate it in the UK, wherever you have the station, as long as the station has the proper license from the ITU. I don't know if it makes sense. It's allowed, but it's two different things that you need to take care of.
Yeah, but keep in mind, there is no unified European space law. This is a big issue for everybody. So every state has its own specific quirks. I can tell you about the Netherlands, for example, you can't, literally. There needs to be an agreement that is in between the agencies. So in our case, now RDI, that's the Dutch telecommunication agency, with the other country. We have done some of these activities for India, for example, and there we had an official letter via the Indian embassy. So ISRO, that was the customer. Basically, it was a student satellite that had issues, and we have commanded it to fix something. But yeah, it was an official agreement in between the governments. So this is the problem. We have tried something similar with other nations. I can make you the example of Ireland. This is actually foreign politics. Foreign politics in the Irish law is of only competence of the parliament. So unless the parliament sits down and agrees that that satellite can be commanded by a foreign nation, this is not possible. But that takes months to enter into the parliament agenda. So it really depends. That's, I think, but keep in mind, Europe is discussing a unified space law at the moment.
Now, just to add a little bit of complexity, if anyone here in the United States wants to do this, what you're asking, good luck. It really is difficult because the FCC is involved. We don't talk to the ITU. As a U.S. citizen, I do not get to talk to the ITU. Okay? I talk to the FCC, and the FCC talks to the ITU. So if I want to put a ground station in another country, like we're working with GroundCom, when I file that, I have to file my license for my satellite, the license for my ground station in the US, then I have to file separate licenses for GroundCom. And then it goes to ITU, and then you get the complaints from other countries that say, well, we don't want you flying over using that frequency, which can happen. And yeah, it's a very long, complicated process. So the easy solution is if you license your satellite in a country, have your ground station in the same country, you will save yourself a lot of headache. Or you hire a company that knows how to do it.
Yeah, I mean, I think we probably should do a panel on regulation next year. Certainly, we're trying to get more speakers in that. We don't really have too many regulation speakers at all, but it's such a common topic, and it's very nuanced, you know. So every country in the world has different laws. Some countries are very pro small satellites and very easy to work with, and some countries are really not, and it's almost impossible to get a license. And then you also have the complication of a lot of countries are flying their first ever satellites, like Ireland launched last week for the first ever time. We looked into like trying to go to Ireland years ago and doing something in Ireland, but they literally didn't have anybody to like ratify a satellite back then. It's like 10 years ago, so it's so subjective, and yeah, I think probably merits like speakers and panels probably next year to kind of sort that out. Do I have one more question? Because I think we're running a little bit behind the schedule.
Time for one more question. So does anyone have one? I have one myself.
Sure.
So I work with a lot of teams, and a lot of them are very different stages. They tend to be very like engineering heavy, so they tend to get the technical stuff worked out a lot. But for teams looking to get ahead with their first satellite, funding is the biggest issue. But we've got a lot of different approaches here. We've got guys getting funded from the university who do some grant writing. We've got a little bit of a VC investment from a company who managed to get some like contracts from the Air Force and things like that. So how would someone go ahead trying to fund their first project?
Who wants to answer that one? Joe?
Okay, the first source that you're going to have for funding is your own pocket.
Yeah, I guess on our end, like Alba's been funded pretty much every type of way. We've done Kickstarter back in the day. We've done small grants. We've done big grants. We've done 𝗖cie contracts. We've had customers, done R&D tax credits, and literally 8 years into the company, we took on an investment for the first time. But that wasn't the first port of call. Obviously, we tried to get some credibility first. We tried to fly some satellites first, and then that just makes life a lot easier. But I see it's the chicken and egg. Like making a model of a PocketQube is quite cheap. Maybe like single-digit thousands just to get a prototype. And the more that you can show people that you have some degree of credibility, whether that's just a model that goes beep or whatever that is, I think that's a really great way to start, and then use that. It's really a credibility feedback loop where you're trying to show that you can deliver stuff and that people can trust you with their money. And if you get a 𝗖cie project, that you can deliver it. If you get a national grant project, you can deliver it. If it's customers, that you'll get them what they ordered. Whether it's a launch or a radio or a process or whatever the thing is that you're sort of flogging. So there is no easy answers to the funding, and I think as well, like hopefully as the community grows, there will be more market opportunities. So we're seeing a lot more interest in like demand for like buses and things, and we're referring to other folks like Pablo and stuff who's got capacity to build them and stuff. So I think as the demand grows for more and more products, that'll create more opportunities for folks to kind of step in, and if somebody has a really good radio, they could sell it, and I'm sure a lot of people in the room would buy that radio, sort of thing, and that's part of the idea of the conference as well, is to try and make more businesses revenue generating and ultimately cash flow positive ultimately, and that just grows the whole sector, So yeah, any more questions? Are we good?
Can I add one little thing about when you go to get investment? Okay, don't ask for money. Okay, go to investors and ask for advice on how to get money. Okay, if you ask for advice, you get money. If you ask for money, you'll get advice. That's the way it works.
And that's Joe's advice. Okay, I think we're going to have to wrap up there because we're a bit behind schedule. But a big round of applause for the panel.